Hey, geometry class. This is our last section in this chapter. We're going to be looking at a couple other quadrilaterals, and this is going to conclude all of the types of quadrilaterals that we'll be looking at. And we've studied them all after this point. So far, we've done parallelograms and squares, rectangles, rhombuses, and now two other special quadrilaterals are kites and trapezoids, and that's what this lesson is going to cover. So let's go ahead and get started. First thing we're going to look at is what is a trapezoid? Well, a trapezoid is a quadrilateral with exactly one pair of parallel sides. And what we call these parallel sides, you see right here, the ones that have this symbol right here are parallel. And they are known as the bases of our trapezoid. Trapezoids have two bases. And then another thing that they also have, the sides that are not parallel to each other, are called the legs of the trapezoid. Okay, so that is what a trapezoid is. Another thing that we're going to look at is a special case of a trapezoid called an isosceles trapezoid. And I'm going to compare it to what we've learned in triangles before. Triangles, we had something called an isosceles triangle. Okay, we learned that an isosceles triangle, the legs of that isosceles triangle were congruent. And we also had a side called the base. Same thing goes here. The two parallel sides are our bases, and then the other two legs of our isosceles are going to be, or of our isosceles trapezoid, are going to be congruent, and that's what makes it an isosceles trapezoid. But let's look at some more things about isosceles trapezoids because they have several more properties to them. So let's take a look. So if an trapezoid is isosceles, then each pair of base angles are congruent. So let's think about this. We have two bases on an isosceles trapezoid, or on any trapezoid, actually. So we're going to have two pairs of base angles. The base angles A and D are always going to be congruent to each other, and then the base angles here, in this case B and C, are always going to be congruent to each other. So that is where this property comes from. Each pair of base angles are congruent. Another way you can determine if you have an isosceles trapezoid is this property here. It says if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So if you know, in fact, you do have your bases here are parallel to each other, and then you know for a fact that you have these base angles congruent to each other, then you should know the sides, the legs of these trapezoids are congruent also. So you do have an isosceles trapezoid. One other property about isosceles trapezoids is this. It says a trapezoid is isosceles if and only if its diagonals are congruent. This only goes along with isosceles trapezoids because let's see, let's look at a regular trapezoid. Okay, here is just a normal trapezoid that is not isosceles. If we were to draw in the diagonals on this thing, you would see that one is always much longer than the other one, or at least a little bit longer. In an isosceles trapezoid, those diagonals are going to be congruent to each other. And also another thing is this segment over here and this one here are going to be congruent, and this one here and here are going to be congruent to each other from this intersection point right here. I'll call O. All right, and that's all of the properties I have on isosceles trapezoids and trapezoids, but there are a couple of theorems that we're going to look at. Now, we have something called the mid-segment theorem for trapezoids. If you remember the mid-segment theorem in triangles, this is very similar to that actually. So the mid-segment of a trapezoid is the segment that connects the midpoints of its legs. So what you're going to do is you're going to have a trapezoid. You know it's a trapezoid. And you know that this point right here on this leg is the midpoint. You know this one's the midpoint because each of these segments are being told they're congruent over here and over here. So the line that connects those midpoints together is called the midsegment. And also the midsegment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the base. So that right there is our theorem for the midsegment of a trapezoid. So if we know that these are parallel, all three of these lines, and then we know for a fact that we do have a midsegment here, and it says this right here, that if we add together the two bases, so the length of the two bases, I'm going to call AB and DC, and divide it by 2, that is equal to the length of their midsegment, so MN. And that is how we're going to solve for some x values or variables here in just a little bit. So here's our first example. Please follow along and write this down on your page that you have. It says, in a diagram, ABCD is an isosceles trapezoid, and PQ is the midsegment. So you're being told for a fact that PQ here is the midsegment. That means all three of these sides are parallel. And we are asked to find the measurement of angle B first, and then also find the PQ, the length of the midsegment. So let's first look at finding the measurement of angle B. This is the angle that we are looking for right here. Now remember, on an isosceles trapezoid, the base angles are always congruent. So this side, or this angle and this angle, are going to be congruent to each other. And these two angles are going to be congruent to each other. One other thing about that we've looked at before about quadrilaterals, their consecutive angles are always going to be supplementary. So meaning angle A and angle D are going to add up to 180. And that's how we're going to solve for angle A, which is congruent to angle B. So that's going to get us our measurement for angle B. So solving this right here, the measurement of angle D plus the measurement of angle A equals 180 degrees. Plug in what we do know. We know that angle D is 75 degrees. And we're going to solve for a measurement of angle A by subtracting both sides by 75. So the measurement of angle A after subtracting will get us 105 degrees. And since measurement of angle A and B are congruent, measurement of angle B is also equal to 105 degrees. Now let's put the midsegment theorem into use. What it stated was that the midsegment is equal to 1/2 the base angles, or 1/2 the sum of the base angles. So PQ is equal to AB plus DC divided by 2. And this is the formula that you need to know. I do expect you to memorize it. So just know that the sum of two bases divided by 2 equals the midsegment. And that's what you need to memorize in your head, not necessarily these letters that I have written down here. Okay, so PQ is equal to, now AB is 25, write that in, and DC is 35, and we're going to divide by 2. And let's see, we get a total of 60 here. 60 divided by 2 is 30. So our length of our midsegment here is 30. And that is how we solve for angles and segments in an isosceles trapezoid, or any other trapezoid at that too. Okay, so now we're moving on to another quadrilateral called a kite. A kite is a quadrilateral that has two pairs of consecutive congruent sides, but its opposite sides are not congruent. Let's take a look at what a kite looks like. I'm sure everyone can imagine what a kite looks like because a kite in real life that you see, a normal shaped kite, um, that comes from geometry. It is also a shape called a kite. So as I stated in the previous slide, the definition of a kite, you can see that here are consecutive sides, MQ and MN, and they are congruent. And then the other two sides, they're known as consecutive sides too, and they are congruent. So two pairs of consecutive sides that are congruent, you have a kite. All right, so in this slide right here, what I'm going to show you is some properties about kites. First, I'm going to follow what this thing says right here. It says draw diagonal MP. So let's draw diagonal MP, meaning draw the line from N to P. There we go. That's pretty good. And then it says, what can you conclude about the two triangles formed? Well, what we can conclude about the two triangles formed, well, we have this side is congruent to this side is congruent to this one, and, well, this side is congruent to itself. Remember, we have by side, 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 two congruent triangles. So we can say they are congruent. And then on this one, it says draw diagonal in Q. Okay, so here, oops, sorry, diagonal in Q. Says, what can you conclude about the two triangles formed here? Well, what we can conclude is they are not congruent to each other, but they both are isosceles triangles, as you can see. Two congruent sides with a base, and then two congruent sides with a base. But they are not congruent. Now it says draw diagonal NQ and MP at the same time. Let's see if I can draw it just as good as I did before. There we go. Okay. Now, here it says, what can you conclude about the diagonals of a kite? Well, if you had a protractor and you were to center it around the intersection, you would see that these two, where they intersect, is a 90-degree angle. So what we can conclude about these diagonals of a kite is that they are perpendicular to each other. So we can say that NQ is perpendicular to MP. And that right there is a property about kites. The diagonals are perpendicular to each other. So here are a couple of theorems that are in your book about quadrilaterals that are kites. It says if a quadrilateral is a kite, then its diagonals are, like we just discovered in the previous slide, are perpendicular. Okay. In other words, if quadrilateral ABC is a kite, then AC is perpendicular to BD. Now, here's another one. It says if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And usually those are noticeable. Like, one end of the kite is much wider than the other, kind of like you see here, BD. So these pair of opposite angles are the ones that are congruent to each other, and these two usually are not. Now, if these two are congruent to each other, well, what you have is a parallelogram, which I guess in ways it is a kite. But let's look at this. If a quadrilateral ABC is a kite and BC is congruent to AB, then angle AC, well, angle A is congruent to C, and B is not congruent to angle D. Okay, so there are some theorems. Now next I think we have an exercise to do. All right, so here is our example on kites. It asks us to use the properties of kites that we just looked at in order to find this particular angle measurement Q. And if you remember from the previous slide, these pair of opposite angles are congruent to each other. And then also, if you remember from one of another lesson that we had learned, that if we have a quadrilateral, the sum of all four of these angles added together will add up to 360. And if you don't remember what I'm referring to, maybe you will here in just a second. So we can get the sum total of the interior angle measures by this formula here, n minus 2 times 180 degrees. And n is the number of angles or number of sides that we have in a quadrilateral or in our polygon. And if we plug in 2 right here, let's go ahead and do that. Let's plug in 2. No, sorry, 4. So that's how many angles we have. And then we have 2 times 180, which is 360 degrees. Now, add up all the angles that you are given in your kite. So, say 83 degrees plus x degrees plus 41 degrees plus another x. That all equals 360 degrees. Now let's combine our like terms. So we're going to get 2x plus 124 equals 360. And now if we subtract the 124 from both sides, we will get, 236. So 2x equals 236. And then now divide by 2 to solve for x, and we get 118. Now, if x is 118, that means the measurement of angle Q is equal to 118 degrees. And there we have it. All right, so we're already here at the lesson quiz. That means we are done with our, just remember the properties that we have looked at. Just to give you a little hint, remember that these two segments are going to be congruent and these two are going to be congruent. So you should know how to find what your x values are. And then the mid-segment theorem, just remember that the two bases that are parallel to each other are going to add up and then be divided by 2 and equal your mid-segment, okay? And then in the kite, it's just like the previous one we did on the slide, the previous slide, where we add up all of these angle measures, set it equal to 360, and solve for x. But here it says what is the measure of the angles that are congruent. So after you find x, plug it back in here and determine which one of the angles is this one congruent to. Okay, so that's all you have to do. We will go over this first thing whenever I see you again. So goodbye, everybody.